Hey coders, how's it going guys? So today we're going to look at this problem, letter tile possibilities. So we are told that we have n tiles where each tile has one letter printed on it. Return the number of possible non-empty sequences of the letter. So what they're saying essentially is that you're given this input AAB, so you need to return all the possible sequences. So it could be A, it could be B, it could be AA, it could be AB, it could be BA. So I think for me to kind of like make sense out of this, I think let's walk to whiteboard and just make sense out of this equation. So essentially what they're saying is that if you're given a letter such as AAB, so you need to return all the possible sequences. So the first sequence, it could be that we have an A, it could be that we have an AA, it could be that we have an AAB, so which is AAB, so it could be that we have B also. If we're starting from here, it could be that we have an AB, it could be that we have a B. It could also mean that we have a BA, because we're not only supposed to consider only the word going forward, we can also consider them backwards. So which means that we can actually start at BA, something like that, and we can have something like BAA, BAA, and we can also have something like ABA, ABA. We can have something like BAB, yeah, I think those are the letters that we keep. This is how it's spelled, so you can also consider it from this direction, you can also consider it from this direction. So there are multiple ways we can go about this, right? So let's say we are given the tiles as we are told A, B. So what we just need to do is that we need to take elements, then we try to search from the remaining elements, right? Let's say we take this first A, we try to search from these and we make our own combination. Then when we are done with this first letter, we go to the second letter and we take the second A and we see how many combination we can get. So we can do this using depth first search. So by depth first search, I mean we can do this recursively. So let's say you take the first element, which is A, right? So because you've taken A, probably in your search space you had AAB, you took A, so which means that you're gonna be left with A and B because this is out. So in the path you're gonna add A. So let's say you have A and you have your results inside here. So firstly you added your A, so you can think of this as your final output. So I'm just gonna write it here. So you added A, then now from your search space, which is AB, you add another element, which is A. So from your path you add A, then you take this two, you add them into the results, so it's gonna be AA. So here you have your A. Because of you doing this recursively, it's just gonna continue getting those elements. Your search space is reduced to B now. Then you take that B element, so you add it to the path. So now you're gonna have your AAB on the results. Then now that you have an empty array, so you're gonna have to return. Okay, then immediately when you return, because you only had one search space here, so it's fine, you're gonna also return back. So here you only utilize the first element, so you're gonna have to go to the second element. So because of this is a depth first search, you will see in code how we're gonna do it. So every time you take an element, you don't have to include that element in the search space. So I'll show you how we're gonna do this in code. So we're just gonna write some code. So what we're gonna do is that I'm just gonna add all the results inside a set. So a set is just gonna help me to make sure that I add only the unique values. So like I said, we're gonna solve this using the DFS approach. So we're gonna pass it a path. So you can think of a path, like I explained, is like we're just concatenating the letters as we go on. So firstly we can add A, then we add another A, we add B, something like that. So we're gonna take T, which essentially represent tiles. So this is just a given string. So what we do from here is that we check if the path is not an empty string. So if it's not an empty string, then we just add it to the set. So we just say results.add path. So we're adding all the letters that we add to the path, and I will show you how we add them. So I'm just gonna say for I in range, because I want to loop through all the characters inside the tile. So all the characters that are inside the tile, I want to add them inside the path. So I'm just gonna say DFS and take the path, then I concatenate the first letter. So which means that I'm just gonna say path T and I. So what I'm doing here is that I'm saying given this tile, take the first letter and add it to the path. So we have this, and I just literally took A. For instance, we just took A and we just added it to the path. So our path now will become something like this. Because we added A inside our path, we know that we should remove A because we should be looking from other values or other letters. So how can we do that? We're just gonna say T, take the letters from up to I. So you can think of this as me saying that I don't want to select the element I just selected. So I just want to select all the other elements. So we're just going to do it this way. So I'm just going to say I plus 1. So here what will happen is that I'm just going to take AB. As you can see here, I'm just saying T up to I. So I is going to become 0 as we first starting the loop. So it's going to return an empty list. Then here we're just saying I, which is 0 plus 1, so it's going to give me 1. So it's going to be 1 up to so it's going to give me from A and B. So that is going to become my search space as we recursively go through the DFS function. So I think that's all. What we just need to do is that we just need to, because we are told that we need to return the length, so we just need to say DFS, which we call it. So our path is going to be an empty path. Then we're going to pass it the tiles that we are given from the function, and when we are done is that we just need to return. I think I made a mistake here, supposed to be there. Then we just need to return the length of the result. So we just run this code and see. I think I didn't make any mistake. Okay, it seems like it works. I know that in the code, when I was explaining in the whiteboard, I told you that when the list is empty, because as you can see that the tile here, we keep on reducing the space. Because of here, when the list is empty, essentially we're not going to loop through. So the loop won't take place. But if you feel like it, you can also write that statement and say if like the T is empty, then you can just return. So you can do something probably like if T, if not T, you can return. I think it will still work. So you're just saying if my search space is empty, just return, so it will still work as expected. So I think that will do it, guys. Thank you for tuning in, and I'll catch you in the other time. Thanks. Bye.